All right. Hello, everyone. My name is Francisca Tan. I'm the product manager from Tessent Embedded Analytics. And today I'm going to talk about how you can accelerate your RISC-V development with Tessent UltraSight-V. So we know that SoCs today are getting more and more complex, and the time and cost taken to debug and optimize software executing on such complex SoCs are also escalating. With more advanced software application, you get increased software code complexity. On the hardware front, designs have multi-cores, many cores, and with the involvement of multi-chip packaging techniques like 2D, 2.5D, 3D, there are potential issues that need root causing and debugging to mitigate early failures so that the costs of managing these fatal errors could be mitigated. High-end bugs and long-tail problems are difficult to identify and reproduce, that is known. And silent data corruption has been a problem for some years and continue to be an expensive problem to solve and expensive to debug and reproduce as well. So identifying hardware and real-time software issues in complex SoCs today actually require more and multiple efficient methods to debug and also to take into the account that there are multiple iterations involved and it needs to have the ability to scale with complexity as well. So now I'm going to talk about Tessent UltraSight-V, which is our new RISC-V debug and trace solution that can help you reduce cost and the time taken to debug and optimize software executing on your RISC-V processors. We know that run control is fundamental to debugging code running on your processor, and we have that capability through GDB and OpenOCD, but we also take a step further to make sure that you have abilities to instrument your code so that this provide you logging capabilities which will give you added visibility on what's going on with your code execution as well. We know that in complex systems, trace can take up bandwidth. UltraSight-V leverages on the eTrace specification, and this enables us to have highly compressed processor trace. Code compilation and re-uploading of code does take multiple iterations, especially when you're trying to debug and root cause an issue. So UltraSight-V also provides a mechanism for fast system memory access, and that way you can do a very fast code upload, which also can reduce your time taken when you're trying to debug and test. I should also mention that UltraSight-V is compatible with third-party tools, such as VS Code, and the embedded IPs in UltraSight-V are also compatible with Lauterbach Trace32 solution. I mentioned that UltraSight-V is a RISC-V debug and trace solution, but I should also say that these hardware and software components in UltraSight-V are actually scalable. There are hooks in there that you can add so that you can scale the solution to a complete system-level debug, a system-level optimization and monitoring solution as well. And the hardware in Tessent UltraSight-V has been verified by RISC-V core vendors. It is also silicon proven down to 3 nanometer over 3 gigahertz. So let's look at the embedded IPs in UltraSight-V. We have a processor analytic module that provides run control capabilities, enhanced trace encoder that encodes the processor trace in a highly compressed manner. It leverages on eTrace, which is a specification originally donated by Ultrasoc, who was acquired by Siemens, and Siemens continued to play an instrumental role in these eTrace specification. We also have the DMA that provides the capability of fast code uploading, a static instrumentation module that provides the capability of minimally invasive logging mechanism, a virtual console module that replaces the UART interfaces, and it will provide you UART-like capabilities to interact with your embedded software. And as I mentioned before, the message infrastructure is also scalable. So in the future, if you want to extend the solution to a full system level debug, you can have additional embedded analytic modules or monitors added to the message infrastructure. And our communicators also support USB, JTAG, and AXI protocol for PCIe access. On the software front, the UltraSight-V software component provides effective RISC-V debug and trace. It provides run, control, and trace through GDB and OpenOCD. It provides you the capability of integrating it with common IDEs such as VS Code or Eclipse, or if you want to use command line interface, that's also possible. As mentioned, it supports USB, JTAG, and AXI for PCIe access, and it also supports RISC-V extensions and custom instructions as well. So this is a snapshot of the UltraSight-V running on VS Code. It provides the comprehensive run control mechanism, setting breakpoints and during run and pause, stepping through the code through GDB and OpenOCD. And the instruction trace is also reconstructed to assembly or C format through GDB, as shown in the picture here. There is also, as mentioned before, there is also a mechanism to do fast code upload using the DMA, and this would provide you, it can be 70 to 100 times faster than normal GDB load, which is very useful if you have to do it multiple times, when you're recompiling and re-updating and retesting, and if you're dealing with certain code application where it is a sizable amount of code, this can significantly cut down the amount of time that you spend on debugging. We also provide printf-style logging macros, as you can see in the picture here. And these macros can take an equivalent of 5 instructions compared to printf, which can take many instructions, like 100 instructions. There is also capability to use these macros to print out the timestamps as well, which would be helpful for performance analysis. And also, if you use the UltraSight-V solution, as mentioned, it does come with a virtual console capability, so you can interact with your embedded software using UART-like capabilities, using Telnet, for example. So I should mention that the instruction trace support in UltraSight-V supports the RISC-V trace mandatory features, and also the RISC-V trace optional features. And on top of that, it also has capability called cycle accurate trace, which will provide information on when your instructions retire. Again, this information would be very useful if you're doing performance analysis, for example. UltraSight-V also comes with a UVM verification IP that can help the user, the hardware engineers, verify that the modules are correctly connected to each other and to the SoC components as well. It comes with UVM sequences and example integration tests as well. And I should also mention, as mentioned earlier in the presentation, that our embedded IPs in the UltraSight-V solution does support Lauterbach Trace 32 solution. And if you want more information on that, you can visit our website. We also have a case study with Seagate on our website talking about how they use our RISC-V solution in their situation, and we have other collateral there as well. So thank you very much. Come and visit us at our booth at G9, just at the back there. And there are other talks happening as well by my colleagues, so please come and join our presentation throughout the day. Thank you very much.